Hey, pre-calculus students, today we are going to look at building the unit circle. And the unit circle is kind of the foundation of trig. We're going to graph it. We're going to use it for identities. So this is kind of the beginning of the foundation of the rest of the semester. So what are we starting with? We are starting with understanding the 30, 60, 90 right triangles and the 45, 45, 90 right triangles. So I'm going to write up the rules for these, and you can add this to your page in your interactive notebook. But let's just start with the rules. So when you have a 30, 60, 90, you have three sides. We're going to call the short side x. The long side takes that short side and multiplies it by the square root of 3. So if your short leg is 5, your long leg is 5 times the square root of 3. Now, to find the hypotenuse, you take the short leg and you double it. So for example, if the short leg is 5, the hypotenuse would be 10. So what happens if we have our hypotenuse with a value of 1? Well, if you take 2x and you set it equal to 1, that means x, or the short leg, would have to be 1/2. So that makes this side 1/2. Well, if you have the short leg at 1/2 and you take 1/2 and multiply it by the square root of 3, you get 1/2 times the square root of 3, which is also known as root 3 over 2. So these dimensions are the three that you need. The fact that the hypotenuse is 1, the short leg is 1/2, and the long leg is square root of 3 over 3. So I'm going to erase I don't call it, it's unnecessary information for memorizing this triangle, but I wanted to show you where it came from. So short leg is 1/2, long leg is root 3 over 2, and the hypotenuse is just plain old 1. Okay, and that's your 30, 60, 90 rules for hypotenuse of 1. Now let's look at the rules for a 45, 45, 90. The rules are x, x. These two legs are the same because both of these angles are the same. So it's an isosceles triangle. And then the hypotenuse is x times the square root of 2. So if this leg is 6, this leg would be 6, and this leg would be 6 square roots of 2. But what happens when the hypotenuse is 1? Well, we take x square root 2, set it equal to 1, and then solve for x. So we're going to divide by the square root of 2. That means each of the legs is equal to 1 over the square root of 2. Well, we can't leave it like that because we're dividing by an irrational number. So we're going to multiply by a root 2 and a root 2 just to clean it up a little bit. And that means x is equal to the square root of 2 over 2. Now, those are the two legs you're going to have to memorize. So if the hypotenuse is 1, each leg measures the square root of 2 over 2. So these are the two triangles that you need to know very, very well as we work the unit circle. So as we build this unit circle, we're going to start in quadrant 1. We're going to start with the angle 0 to 90. Now in radians, we know that is 0 radians, and this is pi halves radians, halfway around to pi. So we're going to be talking it in terms of degrees and radians. Now, for the first position, okay, we're going to take and pick a triangle up and make this little 30-degree angle. Now for that 30-degree angle, I'm going to take a 30, 60, 90 and place it right here. Then we're going to look at a 45-degree angle, which is halfway to 90. And to find those sides or those positions, I'm going to use a 45-degree triangle. And then the last position in the unit circle we're going to memorize is this 60-degree angle. Well, where does that come from? That we go back to a 30, 60, 90, but it's flipped around, and that's this position. Okay? So we're going to take the sides we just looked at and then come up for ordered pairs for the positions on the unit circle. So now let's build it out. Okay? So we're going to start with our 30, 60, 90. We're going to start with quadrant 1, 0 to 90 degrees. So the first position is this, well actually is this position. Now on a unit circle, the radius is 1. So this position has the ordered pair 1, 0, because this length is 1 and we're up and down 0. Now for the 30-degree angle, this angle right here, okay, to get to this position, I have gone out and then up. So how far did I go out? Well, that's the length of a 30, 60, 90's longer leg. And we know that from the first slide as √3 over 2. We know this up direction is half, because it's the short leg of a 30, 60, 90. So this ordered pair is square root of 3 over 2, 1/2. Because that is your out and your up to get to that position. Now, to get to the 60-degree position up here, we again are going to use our 30, 60, 90. So let's go back and mark it. Okay, we're going over 1/2 this time, and we're going up the square root of 3 over 2. So that means this position is over 1/2 and up √3 over 2. So the x direction is 1/2 and the y direction is √3 over 2. And that's how we're going to build out this first quadrant. Now this position is a vertical angle. It's a 90 degrees, so that means I'm going out and back 0 but up 1. And that's how we build it. Now, to build out of this first quadrant, we're now going to reflect, okay? And we're going to take these positions and they're going to reflect across the circle. That means over here in quadrant 2, I'm going left and then up. Well, anytime you go left in quadrant 2, you're going to have a negative followed by a positive coordinate. So that means this position is -1/2 √3 over 2. And this position here is reflected across, and that is -√3 over 2 and +1/2. Now from here, we're going to reflect again to quadrant 3. We know all coordinates in quadrant 3 are negative, negative. So again, we're just going to reflect this straight down to here. So that's going to be -√3 over 2, -1/2. And let's stop for a second and see where that's coming from. That's my long leg and that's my short leg. Okay, so I'm going to reflect this other one straight down here. Where's that coming from? Short leg, long leg, but my signs are -1/2 and -√3 over 2. This position, oh, I've skipped the 180. This one is -1, 0. Now, that makes this position 0, -1. Now let's go back and add our angles, because I haven't really talked about angles. This one's 30, this one's 60, This one's 90. What is this one? This one's 120 degrees. What is this one? I added another 30. This one's 150 degrees. And then if I go all the way to here, this one's 180. So those are your increments of 30 degrees. Each time we're adding 30. So that makes this one 210. And if we add another 30, that makes this one 240. If we add another 30, that makes this 270. And that makes sense. That's 90 plus 90 plus 90. So if we add another 30, that's a 300-degree angle. So starting from here, I'm going to go around 300. Then this one's 330. And then we're over here to 360. Now, I need to do this last quadrant of ordered pairs. So I want you thinking long leg, short leg. So we need this position for the angle 300. We know that we're going a positive direction and then a negative direction. So in quadrant 4, the ordered pairs are going to be positive followed by a negative. Those are the signs. So that means a positive short leg, which is the 1/2, and then a negative root 3 over 2, the long leg. So that's 1/2 negative root 3 over 2. Now where is it getting reflected from? It's reflected from this position at 240. It's reflected straight over. This one's going to get reflected over to here. Well, this one is the longer leg, which is root 3 over 2, and the short leg, which is 1/2. So this becomes root 3 over 2, and that's your x-coordinate, so it's positive. And then the y-coordinate is negative 1/2, because it's the short leg and we're going down. Okay, those are all the angles, and these are all the ordered pairs for your 30, 60, 90 families to create the unit circle. So now let's look at the 45, 45, 90s. So for these, we're going to take, and there's only one position in quadrant 1 that we need to look at. So again, let's go back and review our degrees. So this is 0, this is 90, this is 180, this is 270, and if you go all the way around, this also represents 360. Now, as far as these 45 degrees, this one's halfway and it's 45. Where does that come from? It's this 45-degree angle of rotation around the circle. You add 45, we hit 90. We add another 45. This is 135. Add 45, we hit 180. Add 45, that's 225. Add 45, we're at 270. 270 plus 45 is 315. And 315 plus 45 is 360. So those are all the angles associated with this 45-degree position. Now, ordered pairs. Let's go through and add the ordered pairs. We know this one's already 1, 0. Let's pick up this 45-degree angle and think about that shortcut. If the hypotenuse is 1, what do we know each leg is? And we just figured those out a minute ago. That's root 2 over 2, and this is root 2 over 2. Those are the lengths of the sides. So over root 2 over 2, up root 2 over 2, that is the ordered pair for the 45-degree angle. Root 2 over 2, root 2 over 2. It's kind of nice, it's isosceles. We know this one is 0, 1. We've already labeled it. Now what's going to happen over here? I'm going to take my 45-degree angle, triangle, and I'm going to place it here. Well, what's the only difference between quadrant 1 and quadrant 2 are the signs. The signs are negative followed by a positive. So this position is the negative root 2 over 2, positive root 2 over 2. For 135 degrees. And then of course we know 180 is negative 1, 0. Let's hit 225. 225 is going to take our 30, 60, 90 triangle, and I'm going to flip it down. So I'm going to go ahead and flip it down, and that creates this position. Well, what's this position? Let me grab my red pen. We know that in quadrant 3, both signs are negative. So that's going to be negative square root of 2 over 2, negative square root of 2 over 2. So those are the ordered pairs for 225 degree angle. Both are negative root 2's over 2. At 270, this is 0, negative 1 again. And then at another 45, we're at 315. And we know in quadrant 4, we have a positive followed by a negative coordinate. So that's going to be square root of 2 over 2. And negative square root of 2 over 2 for that position at 315. So positive, negative. Okay, so we've talked about 45 degree angle triangles creating these 4 positions, 1, 2, 3, 4. We also are adding 45, so we have to kind of think about 0, 90, 180, and 270 also. So now at this point, you should have all these positions labeled. Now, we haven't talked about radians. So let's go back. I'm going to erase all this. And we're going to look at radian measure. So the radian measure on a unit circle works like this. 0 radians and then 2 pi if we go all the way around the circle. Okay, we just labeled this from 0 to here as pi, right? 180 is equal to pi. So that means the 90 is pi over 2, or half of it. Now half of the half is right here at pi fourths. So that means at 45 degrees, you have pi fourths. At 90 degrees, you have pi halves. So if I take and go to this position, which we just labeled as 135, that's 3/4 of the way to pi. So that's 3 pi fourths. That's 135. Then at this position, that's 5 pi fourths. Add another pi fourths, and that's 3 pi halves. That's 1.5. And then at this position, that is 7 pi fourths. So we're adding a pi fourths each time. So let's look at it. 1 pi fourths, 2 pi fourths, that's pi halves, 3 pi fourths, and 4 pi fourths. 5 pi fourths, 6 pi fourths, 6 pi fourths reduces to 3 pi halves, 7 pi fourths, and then 8 pi fourths is 2 pi. So I'm going to write those just to help you see it. I'm going to put those in green. They're not reduced. We want to use the reduced. But you can see I'm really just counting in pi fourths. 3 pi fourths. This one's 4 pi fourths, or just 1. 5 pi fourths, we keep that written as 5 pi fourths because it won't reduce. 6 pi fourths is right here, but we reduce it to 3 pi fourths, or 3 pi halves, and then 7 pi fourths. And this is what? 8 pi fourths. Now, what we want written down is what's in red. Now let's go back and talk about the pi 6, or the 30 degrees. Okay, this is 30 degrees, which is 1/6 of pi. Well, where are we getting that 1/6? I'm going to take from 0 to pi, and I'm going to divide it into 6 parts. 1, 2, 3, 4, 5, 6. So I'm taking 180 and I'm dividing it into 6 parts, and that makes 30-degree angles. So 30, 60, 90. 90 plus 30 is 120. 120 plus 30 is 150. 150 plus 30 is 180. And if I take this in pi 6, I'm just going to add pi 6 to get each of the green lines. So 1 pi 6, 2 pi 6. Now we don't call it 2 pi 6, we reduce it to pi thirds. This one's 3 pi 6. But what do we reduce that one to? Pi halves. That's halfway to pi. This is 4 pi 6. But we don't write 4 pi 6 because that reduces, so that's 2 pi thirds. Add another pi 6. This one's 5 pi 6. This one won't reduce, so we just leave it as 5 pi 6. And then this is 6 pi 6, which we also know as pi. That means this next position, when we count by 6, is 7 pi 6. The next position is 8 pi 6. Well, 8 pi 6. We reduce that to what? 4 pi thirds. This is 9 pi 6, which is 3 pi halves. We've already named that one. But if I take 9 pi 6 and I add another one, that's 10 pi 6. And 10 pi 6 reduced is 5 pi thirds. That's the one we want to memorize. The next one after 10 pi 6 is 11 pi 6. That one won't reduce. And then 12 pi 6, we recognize that as 2 pi, a full circle around. So let's highlight pi 6, pi thirds, pi halves, 2 pi thirds, 5 pi 6, pi, 7 pi 6, 4 pi thirds, 3 pi halves, 5 pi thirds, 11 pi 6, and 2 pi. Now we're going to memorize all this, okay? So let's look at the full unit circle. And I want to analyze this just a little bit. I'm going to clear this off for a second. We don't need tangent. We just need to look at our unit circle. So on the unit circle, you're going to have 2 angle measures in each of these positions. You're going to have a degree and you're going to have a radian. At each of these positions, you're going to have an ordered pair, a length to the x direction and a height in the y direction. So each position has 2 degrees, one in angles, one in radians, and 2 positions for the coordinates. So you're going to have 4 notations at each position. So you've got a radian, a degree, and an ordered pair. A radian, a degree, and an ordered pair. A radian, degree, and an ordered pair, all the way around the circle. Okay, so as you do this, you'll need to have this memorized. Now to memorize it, it can be a little tricky. So I'm going to give you a few pointers on how to do that. Okay, you're going to highlight first when you're looking at these as 30, 60, 90s and 45, 45, 90s. So I'm going to highlight in blue your 30s. Those 30, 60, 90, every time you're adding 20 degrees. 120, 150, 180. We'll add 30, 210, 240, 270, add 30, 300, 330, 360. So that's how to memorize the angles. Very easy, adding your 30s. Then you're going to memorize your angle of 45s. Well, that's the one in between. So 0, 45, 90, 135, adding 45s each time, 180, 180 plus 45, 225, add to 45, 270, add 45, 315, add 45, 360. So that's how you're getting those angles. Now, for the radian measure. This is the best way to memorize the radian measure. You're going to memorize quadrant 1 and then do reflections. So the first one is pi over 6. So notice these are all just pi, 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 pi on top. 6, 4, 3, 2. See how it's descending? 6, 4, 3, 2. Memorize that and you're going to have it. Because what you're going to do is you're going to reflect over here. 6, 4, 3, 2. It's going to do the same thing from the x-axis. 6, 4, 3, 2. 6, 4, 3, 2. Each time your denominator is 6, 4, 3, 2. Now, now we need to look at the numerator. So the first quadrant has all pi's. The second quadrant has all pi's, but you have a different number, and I call this the birdie. And if you play any golf, you know what birdie is. It's one value below par. So if you have a par 5, you're going to shoot a 4. If it's a par 3, you're going to shoot 2. So it's always one less. So your numerator is one less than the denominator. So 5, 6, 3 fourths, 2 thirds. And that's how you remember quadrant 2. It's a birdie. Well, what do you get in quadrant 3? You get a bogey, one above. So if your denominator is 6, your numerator is 7. Denominator is 4, numerator is 5. Denominator is 3, numerator is 4. So this is the bogey quadrant. Now, there's no easy way to remember this one. So you've probably heard of the 7-Eleven. It's a grocery store, gas station, that used to be open. If you watch Stranger Things, you probably have seen the 7-Eleven. So this is how you remember quadrant 4. When I was 5, I went to the 7-Eleven. When I was 5, I went to the 7-Eleven. So 5, 7, 11. So if you write in your denominators a 6, 4, 3, 2, working from the x-axis, you can now get your numerators by using birdie, bogey, and when I was 5, I went to the 7-Eleven. Okay? And that's how you can piece it all together. So you need to memorize this unit circle, front to back, back to front. You need to know every position on here in your sleeve.